Imagine a world where every app you open, every website you browse, um, every digital service you interact with just works.
Seamlessly.
Effortlessly, yeah. From ordering your morning coffee with a tap to managing, the intricate logistics of a global supply chain,
Mm,
this isn't magic, right? It's the result of incredibly meticulous design, a hidden architecture that underpins our entire digital existence.
absolutely. But think about the flip side.
Exactly. What happens when that design is flawed? When the blueprint isn't clear?
Well, chaos,
Hmm.
misunderstandings. You get project failures, often pretty catastrophic ones.
The digital world truly doesn't run on magic. It runs on incredibly well thought out systems.
Yeah.
And learning to design those systems to create those, flawless blueprints, it starts right here.
That's the core of it.
Today, we're embarking on a deep dive into the very heart of that design, structuring system process requirements. We're pulling foundational insights from Modern Systems Analysis and Design by Velachik and George, the 10th edition, 2024, specifically focusing on Chapter 7.
A really key chapter.
Definitely. And this deep dive is for anyone, really. Building a future in information systems, computer networking, cybersecurity, or just looking to supercharge their professional growth.
Whether you're a student, maybe at Tarleton State University's Dr. Sampak College of Business, or already out there working.
Right. We're here to help you blend that academic insight with real-world tech applications, making these essential topics, accessible and hopefully exciting.
Making it stick.
Yeah. Before we zoom in too close, though, remember, if you want more insider tips that could help position you for a bright future in your chosen careers, please take a moment to like, subscribe, and share this deep dive.
It really helps get the word out.
It does. And don't forget to check the description for access to additional resources that you may find incredibly valuable.
Lots of good stuff there.
So let's dig into this. Why is truly understanding how a system works so fundamentally crucial, even if you're not the one, writing the code?
Yeah, that's a common question.
Why can't we just jot down a few ideas, tell the developers what we want, and, let them build it? It sounds simple, but I suspect it's anything but.
You've hit on perhaps the most critical challenge in system development. It sounds simple, but it's really not.
Right.
The answer is, quite simply, communication. Process modeling isn't just some technical exercise for techies.
Okay.
It's the universal language. It helps everyone, business analysts, developers, project managers, even the end users, understand exactly how work gets done and how data flows.
A universal language. I like that.
Because without a shared, precise blueprint, everyone operates from their own mental model, their own idea of how things work. And that's just a recipe for disaster.
Okay, so different people see the same process differently in their heads.
Precisely. Think of it like this. A client wants a house. They tell the architect, I want a big kitchen and a cozy living room.
Sounds reasonable.
Sure. The architect then tells the builder, build a house with a large cooking area and a comfortable common space. Now, if there's no detailed blueprint, no shared understanding of what big or cozy actually mean in terms of, say, dimensions, materials, flow.
So you end up with something unexpected.
Exactly. You have with a house that maybe nobody actually wanted. In the software world, this communication gap can cost projects dearly. We're talking time, resources, but more importantly, completely missing the mark on functionality and user needs.
That sounds expensive.
Oh, it is. In fact, studies consistently show that miscommunication during requirements gathering is a leading cause of project failure, costing companies billions. Process modeling, especially using standardized notations like BPMN, which we'll get into,
Okay.
it aims to create a unified, clear, and efficient mechanism to bridge this gap. It drastically reduces errors that come from varied interpretations. It gets everyone from the CEO down to the junior developer literally on the same page.
So it forces that shared understanding.
It really does. And for you, as future business leaders and information systems professionals, this understanding is absolutely foundational. Your course description even highlights it, right? Emphasizing the systematic analysis, design, and implementation of software systems.
With special emphasis on the processes and skills used in the first 4 stages of the system development lifecycle. Yeah, I remember that.
Exactly. These models are those processes and skills in action. They're precisely the theory and practical application mentioned. They're how you'll guide development, integrate new technologies, and ensure the systems you build actually meet strategic business objectives.
So it's not just academic theory, it's practical application.
100%. This is where you truly apply fundamental systems concepts, KO3, to real-world problems. You're bridging business and tech.
That makes so much sense. It's about building a shared reality before we even start building the actual system. Okay, so let's start with one of the classic foundational tools that helps us do just that. Data flow diagrams, or DFDs.
Ah, the classics. Still very relevant.
Right. This tool helps us visualize how data actually moves and transforms within a system. I kind of like to think of it like tracing the circulatory system of an organization, where data is the lifeblood flowing through every department and function.
That's a really good analogy.
It paints a vivid picture, right? Where information originates, where it's processed, and where it ultimately ends up.
That's a great way to put it. DFDs are essentially a GPS for your data. They show its precise journey, helping us identify where information comes from, where it's stored, and where it's going.
A GPS for data.
Okay.
And the real power here lies in revealing the essential what data needs to exist and move without getting bogged down initially in the how it's technically implemented.
The what's versus the how. That seems important.
It's profoundly powerful because it allows you to focus on the core business logic first. It prevents you from just, automating old, inefficient processes without thinking.
So you don't just pave the cow path, so to speak.
Exactly. You want to optimize the business before you automate it. That logical what is key. Okay, so let's get specific. What exactly are DFDs?
Right. At their core, they're a visual representation of data movement. They illustrate how raw input data gets transformed into meaningful output through various processes.
Input to output through processes. Got it.
And they're critical tools for both understanding existing systems, what we often call as-is systems, and for designing new, improved to-be systems.
As-is and to-be. Makes sense.
They help break down incredibly complex systems into manageable, understandable components. Imagine you're trying to figure out why customer orders sometimes get lost in a big e-commerce system.
Yeah, that sounds like a nightmare.
A DFD can quickly highlight where data might be getting stuck or misdirected. And for non-technical stakeholders, they're often incredibly easy to understand, which fosters much better communication.
Ah, so they help bridge that gap we talked about.
Definitely. They also improve system analysis by clearly identifying inefficiencies, redundancies, or bottlenecks. Plus, they provide a clear blueprint for the system architecture, which makes testing much more straightforward because you've defined the inputs and outputs clearly.
And documentation too, I bet.
Oh, absolutely. A vital documentation tool, helping everyone keep track of how things are supposed to work.
Okay, so we're talking about a visual language for data. What are the essential components, the building blocks of this language that we'd see on a DFD? Maybe we can use the SSADM notation you mentioned and perhaps stick with that university course registration system example.
Absolutely. Let's break it down. DFDs use 4 fundamental symbols. First, we have external entities.
Okay, external entities.
Think of these as the participants outside your system boundary who either send information into it or receive information from it.
Like people or other systems.
Exactly. In our university course registration system, external entities would be the student, the registrar, or maybe an external payment system.
Right.
Visually, they're often represented by an oval or maybe a rectangle depending on the specific notation style. If you see the same entity appear multiple times on a diagram, maybe to avoid crossing lines, a diagonal line inside the symbol usually indicates it's the same one, just repeated for clarity.
Okay, that's a neat trick for tidiness.
It is. And here's a crucial rule. External entities can never connect directly to data stores. There must always be a process in between.
Why is that?
It enforces the boundary of your system. It ensures all interactions with stored data are mediated and controlled by a defined process within the system. Keeps things orderly.
Got it. So entities are outside, interacting via processes. What's next?
Next up are processes. These are the actions or the work performed on data to transform it, store it, or distribute it. A process takes input data and produces output data.
So the verbs of the system.
Exactly. It's essentially a verb.
Yeah.
So for our registration system, examples might be validate student enrollment, register student for course, or generate course schedule.
Okay, clear actions.
And notice we avoid vague terms like process data, because that doesn't tell us what actually happens.
Yeah.
We need specifics. In SSADM, a process is typically a box, often numbered, with a clear name.
And there are rules for processes too.
Yes, a key rule. Every single process must have at least one input data flow and at least one output data flow.
Makes sense. Something has to go in, something has to come out.
Precisely. Processes transform data. They don't magically create it from nothing or make it vanish into thin air. If a process only has input, it's a black hole. Data goes in, never seen again.
Oh.
And if it only has output, it's a miracle. Data appears from nowhere. Both indicate a flawed design in your model.
Black holes and miracles. Good things to avoid. Okay, what's the third component?
Our third component is data stores. These are places where data is stored, whether temporarily or permanently. Think of them as collections of information the system needs to remember.
Like databases or files.
Could be. Or even just a specific collection of data. In our university example, data stores would be things like students, containing student records, courses with course details, or enrollments, linking students to courses.
Okay, the nouns where data rests.
Exactly. They're usually named with a noun, often prefixed with a D and a number, like D1 for students, D2 for courses. Similar processes, data stores generally need at least one data flow writing to them to add or update data, and at least one reading from them to retrieve data.
Otherwise, what's the point?
Right. If nothing writes to it, it's always empty. If nothing reads from it, why bother storing it? And critically, data stores cannot directly send data to or receive data from other data stores or external entities.
Ah, same rule as external entities.
Same principle. Processes must mediate all such interactions. They are the gatekeepers for accessing stored data. It maintains control and structure.
Okay, entities, processes, data stores. Yeah. What's the glue?
The glue is the fourth component, data flows. These simply represent the movement of data between the other elements, external entities, processes, and data stores.
The arrows on the diagram.
Exactly. They're represented by an arrow with a descriptive label indicating the specific data being exchanged. For instance, from the student entity to validate student enrollment process, you might have a course request data flow.
Okay.
Or from register student for course process to enrollments data store, you'd have a new enrollment record data flow.
The labels are key then.
Absolutely crucial. And it's vital to remember the allowed and prohibited connections. Data flows can go between external entities and processes both ways, between processes themselves and between processes and data stores, both ways.
What's not allowed?
What's strictly prohibited are direct connections between two data stores, between an external entity and a data store, or directly between two external entities.
Why no entity-to-entity flow?
Because that interaction happens outside the scope of the system you are modeling. The DFD focuses on how the system interacts with entities, not how entities interact with each other independently. These rules are crucial for maintaining system boundaries and ensuring process integrity.
That truly lays out the grammar of DFDs. It's like these building blocks help us visualize how information really moves and transforms. But systems, especially something complex like a university, can be incredibly complicated. How do DFDs handle that level of detail? Do we just create one massive, incredibly detailed diagram? That sounds like it would be completely overwhelming.
You're absolutely right. One giant diagram would be, well, a nightmare to read and manage. Unusable, really.
Yeah.
That's precisely where the levels of DFDs come into play. We use hierarchical sets of diagrams, a context diagram, then level 1, level 2, and so on, to manage that complexity.
Like zooming in?
Exactly. It's like zooming in and out on a very detailed map. You start with the entire country view, then you zoom into a state, then a city, then maybe even the specific neighborhood. This iterative decomposition allows analysts to progressively add detail without overwhelming the viewer.
That sounds much more practical.
It is. And it's fundamental for applying basic systems concepts, that KO3 again, because it teaches you how to break down complex systems into digestible, understandable parts. It's a core skill for an analyst.
Okay, so where do we start? What's the highest level?
The starting point is always the context diagram, which is sometimes called the level 0 DFD. This is the ultimate high-level view. It represents the entire system as just a single process, often literally drawn as one big circle or bubble.
Just one bubble for the whole system.
Yep. Its only job is to show the system's interface with its external environment. So on a context diagram, you'll only see the system boundary, that single process box, all the external entities that interact with it, and the major data flows entering and leaving the system.
What don't you see?
Critically, no internal processes or internal data stores are shown here. It's strictly about the system's context. For our university registration system, the context diagram would simply show the university registration system as that single process bubble.
Okay.
And you'd see data flows like course requests coming from the student entity, and maybe enrollment confirmation going back to the student, or schedule updates going to the registrar entity.
So it defines the edges.
Precisely. Its key function is to clearly define the system boundary. What is in the system scope and what is out of scope for your analysis. Hugely important first step.
Okay, context diagram sets the stage. Where do we go next for more detail?
Moving down one level, we get to the level 1 DFD. This is where you essentially take a magnifying glass to that single process bubble from the context diagram.
Ah, we crack it open.
You crack it open, you decompose it into typically 2 to 7, maybe up to 9 high-level sub-processes that make up the main functions of the system. This is where we introduce the internal processes and the internal data stores.
So the details start appearing here.
Right. And it's absolutely critical that this level 1 diagram is balanced with the context diagram.
Balanced, what does that mean?
Balancing means that all the external entities and all the data flows that were shown entering or leaving the single process on the context diagram must also appear on the level 1 diagram, connecting to the appropriate sub-processes. You can't just introduce new external flows or entities out of nowhere at level 1 or make existing ones disappear. The inputs and outputs have to match the higher level.
Okay, consistency between levels. Got it.
Exactly. For our registration system, a level 1 DFD might break down the main system bubble into major processes like, say, student login, course search, enrollment management, and payment processing.
Right.
And these processes would be shown interacting with internal data stores like student records and course offerings, and also showing the external flows from the context diagram, like course requests coming into enrollment management.
I can see how that starts to build a picture.
It does. And this level of detailed understanding of system functions is also where your ability to implement use case diagrams, SO1, often begins as you start to see the different functional areas the system needs to support.
Makes sense. So what if one of those level 1 processes, like enrollment management, is still really complicated?
Good question. If a process in a level 1 DFD, or any higher level, is still too complex to understand easily, we go to lower levels, level 2, level 3, and so on.
Keep zooming in.
Keep zooming. Any complex process from a higher level can be further decomposed into its own set of sub-processes on a lower level diagram. This continues until each process reaches what we call its primitive level.
Primitive level.
Yeah, that's the lowest possible level of decomposition. A primitive process represents a single atomic unit of work like a single decision, a single calculation, or a single basic database operation like retrieve, update, create, delete, or read. Something that can't logically be broken down further in the context of the analysis.
Okay, the smallest building block.
Exactly. And notation-wise, these sub-processes are usually numbered hierarchically. So if enrollment management was process 2 on the level 1 diagram, its decomposition on a level 2 diagram might show processes numbered 2.1, add course to schedule, 2.2, drop course from schedule, and 2.3, check prerequisites.
Ah, the numbering shows the hierarchy.
Yes, it helps you trace back up through the levels. This layered approach ensures you can always dive deeper when necessary to understand the detail, but you can also step back to the higher levels without losing sight of the overall system structure. It's all about managing complexity.
That's a really powerful way to manage complexity, letting us abstract away detail or drill down depending on, who we're talking to or what problem we're trying to solve. But you mentioned something earlier about what versus how, and it seems like a really fundamental distinction. Can you elaborate on why that's so crucial for analysts?
Ah, yes, the logical versus physical distinction. It's arguably one of the most important concepts for any systems analyst to really internalize. Getting this right often determines whether you build a truly innovative, efficient solution or just end up, automating existing problems.
Oh, tell me more. Logical versus physical.
So a physical DFD describes how a system currently operates or how a future system will operate in terms of implementation specifics. It includes all the physical details, who does what, which person or department, what specific technologies are used, like a particular software or database, what manual procedures are in place, even temporary things like paper forms or spreadsheets.
So it's very concrete, very implementation focused.
Exactly. It's a snapshot of the current implementation or the planned future implementation. For instance, a physical DFD might show registrar's assistant manually enters data from paper enrollment form into the old mainframe system using Terminal X. Very specific.
Okay, I see. What about the logical DFD then?
In stark contrast, a logical DFD describes what the business needs to accomplish. It focuses purely on the essential activities and the core business logic, entirely independent of how they are currently or will be implemented. It abstracts away all those physical details, the people, the specific tech, the paper forms.
So it's the essence of the process.
Precisely. So instead of registrar's assistant processes paper enrollment form, the logical DFD would simply show a process like process course enrollment. The beauty of the logical view is that it forces you to ask fundamental questions. What is the true purpose of this step? What data must move and what transformation must happen, regardless of whether it's done on paper, in an app, or through an email?
That sounds like where the real analysis happens.
It really is. The typical progression in a real-world analysis project often moves through 4 stages of DFDs. You start by understanding the current physical system, how things work now.
Okay, document the reality.
Then you abstract that into a current logical view, what the current system does, stripping away the implementation details. This often reveals inherent inefficiencies in the logic itself.
Ah, you see the underlying process flaws.
Exactly. From there, you envision the required logical system, what the new optimized system should do, based purely on efficient business needs, completely free from the constraints of the old ways. This is where innovation happens.
Designing the ideal what?
Right. And finally, you detail the required physical system, how that new optimized logical system will be implemented, specifying the new technologies, roles, and procedures.
What, then how? Logical then physical.
You got it. This progressive approach is absolutely key for anyone applying basic economic and organizational models, KO1 and KO2, because it allows you to identify profound inefficiencies in the current logical model that might be completely masked by the physical implementation details.
So you fix the core process before automating it?
Precisely. You can design truly efficient future states that leverage technology creatively, rather than just, digitizing an antiquated, broken process.
Yeah.
Imagine a company that just builds an app to scan old paper forms without rethinking the entire data capture, validation, and approval process. That's a classic failure to move from physical to logical thinking first. Huge missed opportunity.
That's a really powerful distinction, focusing on the essence of the business first before getting tangled in the weeds of execution. It really seems like it unlocks creative problem solving. But, designing these diagrams, well, sounds like it could still be tricky. What are the common pitfalls people fall into, and how do we avoid them?
You're right. It's definitely an art as much as a science, and there are certainly common traps analysts can fall into. Building good DFDs, or really any process model for that matter, requires careful attention to a few key principles: completeness, consistency, naming conventions, and flow integrity.
Okay, let's break those down.
Absolutely. And getting these right is also where you demonstrate your understanding of systems, analysis, and design concepts, W01, and your ability to communicate them effectively in writing or visually.
Right, important for the course.
Definitely. So first, completeness. This is paramount. It means every necessary component, all the external entities, processes, data stores, data flows, must be included and thoroughly described. This description usually isn't on the diagram itself. That would make it too cluttered.
Where does the description go then?
It goes in a separate document, often called a data dictionary or project repository, which acts as a glossary defining every single element on your DFDs. Without that detailed description, your diagram becomes ambiguous, forcing readers to guess what customer record or process order actually means.
So the diagram and the dictionary work together.
They have to. Second, consistency, which is often called balancing, is absolutely vital across the different levels of decomposition we talked about.
Level 0, level 1, etc.
Exactly. If a data flow called course request enters a process bubble on the level 0 context diagram, it must be accounted for with the same name, entering one of the sub-processes in the level 1 diagram that breaks down that bubble. Inputs and outputs must be conserved across levels.
So no data magically appears or disappears when you zoom in?
Precisely. This prevents those black holes data going into a processor level and never coming out, or miracle processes data coming out of a processor level with no corresponding input from the higher level. If your DFDs aren't balanced, your system description is fundamentally broken. It simply won't work as described.
Okay, completeness and consistency. What else?
Then we have naming conventions. These might seem minor, but they massively impact clarity. External entities should be clear, descriptive nouns, student, registrar. Processes must start with strong active verbs followed by an object, validate enrollment, calculate grade, not just vague terms like processing or update.
Verbs for processes, nouns for entities.
Right. Data stores are always named with nouns, usually plural, like student records, course sections. And data flows should be labeled with the data they contain, like payment details or validated application, not with verbs, which would imply their processes themselves. Clear names reduce ambiguity.
Makes sense. Keep it unambiguous.
Yes. And related to that is flow integrity. Ensure data flows only connect permitted elements. Remember those prohibited connections we discussed. No direct data store to data store communication. No external entity directly accessing a data store. Processes are always the intermediaries. These rules aren't arbitrary. They enforce the logical structure and control within your system.
Sticking to the grammar rules.
Exactly. And critically, remember the basic input-output rules for processes and data stores. Each process needs at least one input and one output data flow. A data store generally needs at least one flow writing to it and one flow reading from it, somewhere in the overall system diagram set, not necessarily on every single diagram it appears on.
To be useful.
Right. If you violate these, your system model implies it either creates data from thin air, consumes data without purpose, or stores data that's never used. All signs of a modeling error.
Okay. Any final guideline?
Just the recognition that creating good DFDs is almost always an iterative process. Rarely is a DFD perfect on the first try. It involves sketching, refining, checking your assumptions with actual users and stakeholders, resolving ambiguities and correcting errors. It's a dynamic conversation captured visually, not a static artifact carved in stone first time out.
So expect revisions.
Definitely expect revisions. And collaboration.
That's really helpful. But it also brings up a point you touched on. DFDs seem great for data, but maybe not for everything.
That's a very important point to raise. While DFDs are incredibly powerful for visualizing data flow and transformation, they aren't a silver bullet for modeling every single aspect of a system.
Okay, what are their limitations?
Their primary focus is, well, data flow. They don't inherently capture other critical aspects, like specific timing requirements. In DLCs, these must happen within 5 seconds. Detailed user interface, interactions, what buttons are clicked in what order, the exact sequence of events, especially under concurrent conditions, or complex decision logic that might depend on multiple factors or rules.
So they show the what of data, but maybe not the when or the detailed how of control flow.
That's a good way to put it. It's crucial to recognize their limitations and understand that DFDs are typically used in conjunction with other modeling tools like state diagrams, sequence diagrams, or process models like BPMN to get a complete, well-rounded picture of the system. Each tool has its strengths.
That's a great clarification. So DFDs are fantastic for clarity on data movement, a crucial piece of the puzzle, giving us the what for data. But it sounds like they don't capture everything about a system's overall operational how, especially the nitty-gritty steps.
Exactly.
So what if we need to zoom in and capture the exact steps, the sequence, the decisions a business takes, especially when we're thinking about maybe automating those processes? Where do we turn then?
That's the perfect transition. That's where we move into the realm of business process model and notation, or BPMN.
BPMN. All right.
If DFDs are foundational for mapping the journey of data, BPMN is widely considered the international standard that takes process modeling to the next level. It's specifically designed to model the end-to-end flow of work, often with an explicit eye towards automation and execution.
So it's more focused on the sequence of actions.
Yes, and the control flow, the decisions, the interactions between different participants or systems. Think of it like moving from a static anatomical chart, like a DFD showing where organs data are, to a dynamic animated video showing how the body functions in motion, like BPMN showing the process steps.
I like that analogy, anatomy versus physiology.
Precisely. What's really fascinating here is how BPMN acts as that critical bridge. It's designed to ensure everyone, from the high-level business strategist designing a new customer service process, to the IT architects figuring out system integration, to the technical developers actually coding it, speaks the exact same process language.
That universal language idea again.
Exactly. And this shared language is absolutely vital for consistent execution and, maybe even more so today, for successful process automation. BPMN was specifically designed from the ground up to support business process management initiatives, or BPM.
BPM, okay.
Offers an intuitive yet surprisingly powerful way to represent complex process semantics, including how they actually execute in software systems. This is critical for anyone learning to utilize standard diagrams for business processes, like activity diagrams mentioned in KO4, because BPMN provides that standard, rigorous notation.
So it's designed for execution almost.
In many ways, yes. So what exactly is DPMN? It's a graphical notation, a set of standard symbols and rules specifically designed to describe the logic of the steps in a business process. It maps out the sequence of activities, the messages that flow between different participants, the decision points, everything.
Who came up with it?
It was originally developed by an organization called the Business Process Management Initiative, BPMI, but it's now maintained by the Object Management Group, or OMG, the same folks who manage UML.
Ah, the OMG.
Yes. BPMN 2.0.2 is the current version, and significantly, it's also been ratified as an international standard ISO 19510. So it's not just some niche notation, it's globally recognized.
That standardization is key, I imagine.
Hugely key. The main advantage is that it creates that standardized link, that bridge, between the way a business describes its processes and how those processes can be technically implemented, often through automation.
You mentioned automation earlier.
Right. This is exactly what enables powerful process automation. Take a real-world example. DHL Group, the logistics giant. They reportedly use low-code platforms heavily based on BPMN to automate numerous end-to-end processes. We're talking handling an astonishing 5 million cases per year through these automated workflows.
5 million cases, wow.
Imagine the efficiency gains, the cost savings, the consistency. It truly demonstrates the real-world impact of having a universally understood, executable process language on large-scale enterprise operations. BPMN makes that possible.
That's an incredible scale. It really sounds like BPMN provides a much richer and more precise language for describing processes than DFDs, especially if automation is the goal. So what are the core elements of this language, the building blocks of BPMN that allow for such detailed modeling?
You're right, BPMN offers a comprehensive set of elements, but they're logically grouped into 4 basic categories: flow objects, connecting objects, swim lanes, and artifacts. Let's start with the main ones. The flow objects. These are the primary graphical elements that define how processes actually behave.
Okay, flow objects, what are they?
We begin with events, which are represented by circles. An event signifies something that happens during the course of a process. It could be a trigger, a result, a milestone, something that affects the process flow. Think of them as the start points, the end points, or important intermediate occurrences.
Circles for things happening. Got it.
There are 3 main types based on timing. A start event, drawn as a single thin-line circle, is what kicks off a process instance. For example, receiving a loan request submitted message could be a start event.
Okay, the trigger.
An intermediate event, drawn as a double-line circle, is something that happens during the process, between the start and end. Maybe it's a specific message arriving, like document uploaded by a customer, or a timer going off, like review deadline reached.
Things that occur along the way.
Right. And finally, an end event, drawn as a single thick or bold-line circle, signifies the completion of a process path. It represents the final result, like loan approved or application rejected. A process might even have multiple possible end events depending on the outcome.
Start, middle, end. Makes sense. What else?
Next are activities, which are depicted as rounded rectangles. These represent the actual work that is performed during the process.
The doing parts.
Exactly. The most basic type is a task, which represents a single atomic unit of work that can't be broken down further in the context of the diagram, like record customer data or send rejection email.
Okay, a single step.
Sometimes, though, a complex group of related tasks can be collapsed visually into a sub-process. This looks like a regular task rectangle, but usually has a little plus sign plus at the bottom. This indicates it can be expanded to show more detail, its own internal start event, tasks, and end event. It helps manage complexity on the main diagram.
Like nesting diagrams.
Sort of, yes. Think of a sub-process like perform credit check, which might actually involve several smaller tasks inside it, like retrieve credit score, analyze report, assign risk rating. You can hide that detail or show it.
Handy for different audiences.
Very. There are other specialized activity types too, like transactions and call activities for more advanced scenarios.
Okay. Events happen, activities do work. How do we make decisions?
That's where gateways come in. Represented by diamonds, gateways are absolutely critical. They control the divergence, splitting, and convergence joining of the process sequence flows. They act as decision points or points where paths run in parallel or are synchronized.
Diamonds for decisions and flow control.
Exactly. There are several types. An exclusive gateway, often shown with an X inside or just plain, means only one possible path can be taken out of the gateway based on some condition. Think of asking, is loan amount $10,000? The flow goes down either the yes path or the no path, but not both.
A simple fork in the road.
Right. Then there's a parallel gateway, often shown with a plus inside. This is used to split the flow into multiple paths that run simultaneously or concurrently. For example, after approving an order, a parallel gateway might initiate send confirmation email and update inventory database at the same time. It's also used later to synchronize these parallel paths back together.
Doing things at the same time.
Yep. And an inclusive gateway, often with an O inside, is a bit more complex. It allows for one or more paths to be taken based on conditions that are evaluated independently. So if an application has missing info and fails a preliminary check, An inclusive gateway could trigger paths for both request missing info and the notify risk department.
More complex branching.
It allows for more flexibility in routing. There are other gateway types too, like event-based gateways, but those are the main ones you'll encounter. Gateways are essentially the traffic cops directing the flow of work through your process.
Okay. Events, activities, gateways. How do they connect?
That brings us to the connecting objects. The most fundamental is the sequence flow, shown as a solid line with a solid arrowhead. This shows the order in which activities are performed within a single process or lane. This defines the primary path, the executable sequence.
The main pathway.
Then there's the message flow, which is crucial for interactions between different participants. It's shown as a dashed line, usually with an open circle at the start and an open arrowhead at the end. It represents messages being sent across organizational boundaries, specifically between different pools. A key rule: message flows cannot connect elements within the same pool.
Only for talking between pools.
Strictly. Finally, an association is represented by a dotted line. It's used to link artifacts, like data objects or text annotations, to flow objects, events, activities, gateways, or sequence flows, providing extra context or showing inputs/outputs.
Dotted lines for annotations and data links. Got it.
Now, how do we show who is doing what? That's where swim lanes come in.
Like lanes in a swimming pool.
Exactly that concept. BPMN uses two main types. A pool represents a major participant in a process, typically a distinct organization, system, or business entity. Examples could be the customer, the bank, or shipping department. A pool typically encloses a complete end-to-end process from the perspective of that participant.
So different companies or big departments.
Right. And within a pool, you can have lanes. Lanes are sub-partitions used to organize and categorize activities according to a specific function, role, or internal department within that participant. For example, within the bank pool for a loan process, you might have lanes for loan officer, credit department, and underwriting.
Organizing tasks within a participant?
Precisely. This explicit segmentation using pools and lanes makes it crystal clear who is responsible for performing which activity. Hugely important for clarity and accountability.
I can see that. Any other pieces?
Just one more main category: artifacts. These aren't core flow elements, but provide additional information to enhance the model's clarity and understanding.
Like extra notes.
Kind of. The main ones are data objects, which show specific data required as input or produced as output by an activity, like a loan application form document. A group, shown as a dashed rounded rectangle, can be used to visually cluster related elements together for documentation or analysis, but it doesn't affect the sequence flow. And an annotation is just what it sounds like: a way to add explanatory text comments directly onto the diagram, usually connected to an element with an association line.
Okay, ways to add more context.
Exactly. So if we were modeling our university course registration using BPMN, you might see the student represented as an external, maybe black box, pool sending a course request message flow to the university registration system pool. Inside the university pool, you might have lanes for admissions office and registrar. Tasks like verify eligibility in admissions and allocate seat in registrar would be connected by sequence flows, potentially going through gateways like prerequisites met. Data objects like student transcript might be shown as inputs. This detailed representation of process flow, interactions, and responsibilities directly supports your ability to implement things like activity diagrams from business cases, that SO2.
Wow, that's a powerful and intricate language. It's really clear that BPMN gives us a lot of expressive power to model things very precisely. But as you said with DFDs, it's not just using BPMN, it's about using it well, right? I've heard people complain it can get overly complex, but you hinted that maybe that complexity often comes from, well, poorly constructed models, not necessarily the notation itself.
You've hit on an absolutely crucial point. Yes, BPMN has a rich symbol set, but a truly good process model, whether it's a DFD or BPMN, is much more than just drawing symbols correctly according to the rules. It needs to be correct, clear, complete, and consistent. If you miss the mark on any of these, your elegant-looking diagram can quickly become a source of confusion, leading to miscommunication, flawed implementations, project failures, and ultimately wasted resources.
The 4 C's. Correct, clear, complete, consistent.
Exactly. And mastering these directly ties into applying effective project management methodologies, KO5, because clear, correct, complete, and consistent models are fundamental tools for planning, communication, and risk management in any systems project. Poor models are often at the root of project missteps and budget overruns.
Okay, so let's unpack those 4 C's. How do we ensure BPMN models meet these criteria, and what are some common mistakes to avoid? Let's start with correctness.
Right. Correctness has two facets: syntactical accuracy and semantic accuracy. Syntactical accuracy means your model adheres strictly to the rules of the BPMN notation itself. The grammar has to be right. Semantic accuracy means the model accurately represents the business reality it's supposed to depict.
Grammar and meaning. Got it. Examples of errors.
A very common syntactical error is drawing an activity that looks like it just stops dead. It has an incoming sequence flow, but no outgoing one. In BPMN, an activity without an outgoing sequence flow technically implies an implicit end event right there. This might prematurely stop that path of the process in a way you probably didn't intend.
Ah, so dangling activities are bad.
Very bad. Always ensure a continuous sequence flow from a start event through activities and gateways to an end event. Every activity should have proper incoming and outgoing sequence flows, unless it's explicitly the very start or very end of that path. Another classic syntactical and semantic mistake is using a message flow, the dashed line, to connect elements within the same pool.
We talked about that message flows only for between pools.
Exactly. Remember, message flows are strictly for communication between different pools or participants, like between the customer pool and the bank pool. Within a single pool, you must use sequence flow, the solid line, to show the order of activities. Breaking these fundamental rules means your model literally doesn't speak BPMN correctly. It makes it impossible for automation engines or even other analysts to interpret it consistently and correctly.
Okay, so follow the grammar rules precisely. What about clarity?
Clarity is about making sure the model is easily and unambiguously understood by all stakeholders, regardless of their technical background, without requiring them to make assumptions. Vagueness is the enemy of clarity.
Examples of vagueness.
Things like vague event labels, just putting application on a start event, doesn't tell you what triggered it. Was it submitted, received, approved? Similarly, unclear conditions on gateways are a huge problem. Just putting a diamond with no labels on the outgoing paths or just labeling it decision leaves everything open to interpretation. What's the decision based on? What do the different paths mean?
So everyone reads it differently.
Exactly. If a gateway isn't clearly labeled with the conditions determining the path, like loan approved, with outgoing paths labeled yes and no or amount $50 K, then every reader will interpret it based on their own assumptions. The fix is simple but crucial. Use explicit descriptive labels for everything. Use verb phrases for activities, verify customer ID, noun phrases for events describing what happened, payment received, and clear conditions on gateway paths: eligible, incomplete, declined.
Be specific.
Be relentlessly specific, explicitly showing external actors, even as black box pools like applicant, and clearly labeling message flows between pools with the content of the message, portfolio requested, portfolio received, also makes interactions unmistakable. Imagine a doctor's prescription to a patient if it's vague or illegible. It's not the patient's fault if they take the wrong dose. Same principle applies to process models.
Yeah.
Clarity prevents errors.
Good analogy. Okay,
Yeah.
Correctness, clarity. Next is completeness.
Completeness means your model describes all relevant paths and scenarios through a process, not just the ideal, straightforward, happy path. Real-world processes have exceptions, errors, and alternative routes.
So think about what can go wrong.
Absolutely. What happens if something goes wrong? What are the alternative scenarios? What are the exception handling paths? For instance, in our loan application example, if the process includes sending a request for additional information back to the applicant, a complete model needs to show what happens next. What if the applicant doesn't respond within the deadline? What if they respond late? What if the information they provide is still inadequate?
You need paths for all this possibility.
You do. Ignoring these less common or exceptional scenarios makes your model unrealistic and brittle. It won't accurately reflect the complexity of the real world, and any system built based on an incomplete model will likely fail when those exceptions inevitably occur. A model that only shows the best-case scenario is actually quite a dangerous oversimplification.
Model the messiness too. Got it. And the last C, consistency.
Consistency ensures that the model is interpreted the same way by all readers, regardless of their perspective, and that the terminology and level of detail are maintained uniformly throughout the diagram set, if you have multiple related diagrams, like subprocesses.
So use the same terms everywhere.
Yes, and maintain a consistent style and level of abstraction appropriate for the audience and purpose. This consistency, especially when coupled with clear documentation in that data dictionary we mentioned, is paramount for demonstrating your understanding and effectively communicating complex system concepts. W01 again. It also aids in developing consistent and accurate data structures, like ensuring the data objects shown in your BPMN process align perfectly with the attributes defined in your UML class diagrams relating to SO3. Everything should hang together coherently.
Correct. Clear, complete, consistent. Those are incredibly practical guidelines. It really drives home that good modeling isn't just drawing pretty pictures. It's about precision, foresight, and clear communication.
Couldn't have said it better myself.
Okay, but stepping back a bit, how does BPMN stack up against other modeling notations we might encounter? We just covered DFDs, and people often mention UML activity diagrams in the same breath as BPMN. When should we choose one over the other? Because, in the real world, you're not always going to use every single tool in the toolbox for every single problem.
That's a fantastic, very practical, real-world question. It's all about choosing the right tool for the job. While both BPMN and DFDs are process modeling tools, they serve slightly different primary purposes and have different strengths.
Okay, BPMN versus DFD recap.
Sure, DFDs, as we discussed, truly excel at providing a clear, high-level overview of data flow and data transformation within a system. If your main concern is understanding what data goes where, how it changes hands, and where it's stored, particularly during the early analysis phases, DFDs are excellent. They give you that structural map of data.
Good for the big picture of data.
Right. BPMN, on the other hand, offers far more advanced and specific constructs for modeling the detailed, step-by-step, executable flow of work in business processes, including complex decisions, parallel paths, exceptions, and interactions across different organizational boundaries, pools and lanes. It's built with that eye towards precise operational description and potentially automation.
So if you need the operational details, the how of the work.
If you need to model the detailed steps, decisions, sequence, and interactions for an end-to-end business process, especially one that might eventually be automated or requires very clear operational understanding, BPMN is generally the stronger, more expressive choice.
Okay, that distinction makes sense. Now, what about BPMN versus UML activity diagrams? They sound kind of similar, both showing steps and flows.
They do have significant overlap, yes. Both can certainly be used to model the flow of activities in a process or system. However, there are key differences in their origins, focus, and typical usage. BPMN was specifically created for business process modeling. Its notation, its concepts like pools and lanes, its event types, they're all designed to be relatively intuitive for business analysts and stakeholders. It has strong, well-defined execution semantics, meaning it's often easier to directly translate a BPMN diagram into an automated process using a BPM engine. Its primary focus is the business process itself.
Built for business processes.
Exactly. UML, the Unified Modeling Language, is a much broader suite of diagrams designed primarily for modeling object-oriented software systems. Activity diagrams are just one type of UML diagram, alongside class diagrams, sequence diagrams, state diagrams, use case diagrams, etc.
UML is a bigger toolbox.
A much bigger toolbox, focused mainly on software design. While UML activity diagrams can model business processes, their notation is sometimes seen as slightly less intuitive for non-technical business users compared to BPMN. And while they can show sequence and decisions, BPMN often provides richer constructs for handling specific business process concepts like message events, timer events, or complex exception handling patterns.
So BPMN might be better for talking to the business side about their processes.
Often, yes. If your primary goal is to model, analyze, improve, and potentially automate business processes in collaboration with business stakeholders, BPMN is usually the preferred and more specialized standard. If you're deep in object-oriented software design and need to model the flow within a specific software method or component as part of a larger UML model set, then a UML activity diagram might be a natural fit within that context. But for standalone business process work, BPMN generally wins out today.
That's a really interesting distinction, especially thinking about audience, because I've heard mixed things in the industry, connecting back to something you mentioned earlier. Do developers actually use these diagrams, BPMN, DFDs, UML, out there in the wild? Or is it sometimes just, something you learn in class and then gets forgotten under the pressure to just get coding?
The perennial, do they really use this stuff?
Yeah.
Question. You're touching on a very real dynamic in the software development industry. The honest answer is, it varies a lot.
No single answer then.
No single answer. The prevalence and type of diagramming truly varies significantly based on factors like company culture, the complexity of the project, the size and distribution of the team, and even the specific development methodology being used, like waterfall versus agile.
So where do you see them used regularly?
In some organizations, particularly larger enterprises or in regulated industries or in very complex projects, diagrams like use case diagrams, sequence diagrams, entity relationship diagrams, ERDs, DFDs, and BPMN are absolutely integral parts of the standard workflow. They're critical for creating shared understanding and functional specifications, for detailed planning during sprint sessions, for database modeling, and for designing and communicating system architecture.
Especially with big teams.
Definitely. Think of those big tech companies coordinating hundreds, maybe thousands, of developers working on interconnected microservices. Clear architectural diagrams and process models become absolutely essential communication tools to ensure everyone understands how their piece fits into the vast, complex puzzle and how the different parts interact. Without them, it would be chaos.
Okay, so scale and complexity drive usage. What's the value proposition people see?
The value proposition for using them, when done well, is significant. I remember a project early in my career, a classic example, where a lack of clear process diagrams for a new customer onboarding system led to months of wasted development effort. Why? Because the development team and the business users had completely different, unstated assumptions about how a critical part of the process should actually flow.
Ouch. What happened?
Once we finally sat down and mapped it out visually, using something like BPMN, the misunderstandings became glaringly obvious within hours. The diagrams effectively replace countless frustrating meetings and emails. They can clarify communication with product owners, clients, and other teams in a way that pages of text often simply can't.
Visual communication is powerful.
Incredibly powerful. Diagrams help identify logical gaps, edge cases, or inconsistencies before a single line of code is written, which saves immense amounts of time and money by preventing costly rework later. They also serve as invaluable guides for onboarding new team members or junior developers, helping them quickly grasp complex system logic or architecture.
Then maybe helps you get a job.
Honestly, yes. Knowing how to effectively create, interpret, and communicate using these standard diagrams can be a significant differentiator for you in the job market. It shows analytical rigor and strong communication skills, truly helping you stand out from the crowd. It signals you know how to think systematically.
Okay, so lots of potential value, but what about the downsides? Why don't some teams use them?
There are definitely challenges and valid reasons why some teams use them less or not at all. A very common complaint is that diagrams can quickly become outdated. As a system evolves rapidly, especially in Agile environments, keeping complex diagrams perfectly synchronized with the living code can require significant discipline and effort. If they fall out of sync, they become worse than useless. They become actively misleading artifacts.
The stale diagram problem.
Exactly. Some developers also argue that certain notations, perhaps parts of UML, feel overly complex or heavyweight for modern, fast-paced development paradigms. They might feel the language itself has evolved past where the diagrams provide the most value compared to, say, well-written tests or code comments.
Is UML seen as old sometimes?
Sometimes, or at least perhaps not the perfect fit for every modern language or framework, some argue. Time constraints are also a major factor. In high-pressure environments focused on rapid delivery, teams might consciously or unconsciously prioritize shipping features over investing time in detailed formal diagramming, especially if they feel they have good informal communication within a small, co-located team. They might opt for whiteboarding sessions that aren't formally captured, or use newer, perhaps simpler modeling approaches like the C4 model for software architecture. It's always a trade-off.
Time versus thoroughness.
It often boils down to that.
So, wrapping up this part, what's the key takeaway for students learning these tools? Are they still worth mastering?
Absolutely, yes. The conclusion isn't that any one tool like DFDs or BPMN or UML is obsolete or the only way. The key takeaway is that the best approach, the best tool, is the one that fits the specific work, the specific problem, and the specific audience you're dealing with.
Context matters.
Context is everything. Learning these tools, especially understanding the principles behind DFDs and mastering a standard like BPMN, provides you with an incredibly powerful and versatile skill set. It equips you to analyze, understand, design, and communicate complex systems effectively in various situations. It directly helps you apply effective project management methodologies, KO5, by giving you concrete tools to better plan, visualize, execute, and de-risk projects. The ability to choose the right diagram for the situation, use it correctly, and clearly explain why it's the right choice, that's the mark of a truly effective and valuable systems analyst or business professional in today's world. Don't just learn the symbols, learn the why and when.
Choose the right tool, use it well, and know why. That's great advice. This has been such a truly insightful deep dive into understanding how our digital world is constructed, really one precise process model at a time.
It's fascinating stuff when you peel back the layers.
It really is. We've journeyed from the foundational data flow diagrams that map the journey of information through that crucial distinction of logical versus physical design, all the way to the modern, powerful business process model and notation BPMN, which helps us visualize and even automate complex business logic.
Hmm.
We've seen how these tools are just indispensable for translating complex ideas into clear, actionable plans, really bridging that critical gap between what the business needs and how the technology gets built.
And that journey truly highlights that whether you're analyzing existing systems, the asses, or designing future ones, the to-be, the clarity, the correctness, the completeness, and the consistency of your process models are just paramount.
Those 4 Cs again.
They are how we articulate the very essence of a system. They make it understandable, manageable, testable, and ultimately buildable. They are the shared language that ensures everyone involved, from the frontline business user making a request to the back-end developer writing the code, shares a unified, unshakable vision of what needs to be done.
So mastering these tools isn't just about understanding technology.
No, it's about shaping the future of how businesses operate, how services are delivered, how value is created. It's fundamental.
Thank you so much for joining us on this deep dive. It's been incredibly illuminating. If you, our listeners, found this valuable, please do take a moment to like, subscribe, and share it with others who might benefit.
We appreciate the support.
We really do. And remember, all the additional resources we mentioned, including more details from that excellent textbook by Valeshik and George, Modern Systems Analysis and Design, are linked right there in the description below.
Definitely check those out.
Yeah, lots more to explore. So here's a final thought for you to ponder as you go about your day. Think about a system you use constantly. Maybe it's how you check out groceries, how you stream music, or even how your university processes something like a transcript request.
Everyday processes.
What process in your daily life, big or small, do you think could be made significantly clearer, maybe faster, or just less frustrating if someone took the time to actually map it out properly with a DFD or maybe a BPMN diagram first? Where's the hidden inefficiency you've noticed?
Makes you look at the world differently.
It really does. Behind every tap, swipe, and click is a system that someone designed. Until next time, keep building the future one process at a time.